Projected 50% increase in aerospace workforce, implications for engineering, manufacturing, and robotics industries by Q4 2025. Overview. As the aerospace industry anticipates a 50% increase in its workforce by the fourth quarter of 2025, profound implications are expected across engineering, manufacturing, and robotics sectors. This report synthesizes current trends, challenges, and strategic responses that various industries must consider to adapt effectively to this impending workforce expansion. Key trends. 1. Talent shortages and workforce dynamics. The manufacturing sector is already facing significant talent shortages, with nearly 60% of manufacturers reporting challenges in attracting and retaining skilled employees. According to a Deloitte survey, if these challenges remain unaddressed, up to 1.9 million manufacturing jobs may go unfilled over the next decade. Consequently, the anticipated increase in the aerospace workforce could exacerbate these shortages, necessitating advanced workforce management tools and improved employee experiences to enhance retention. 2. Technological integration. The integration of robotics and AI is rapidly transforming operational dynamics within industries. Advances in machine learning allow robots to perform complex tasks with real-time adaptability, enhancing efficiency. Collaborative robots, cobots, are particularly noteworthy as they facilitate human-robot interactions, redefining workforce dynamics. Digital twin technology is also emerging as a critical tool, providing real-time analysis and optimization capabilities essential for aerospace manufacturing. 3. Investment in clean technologies. Despite signs of slowing growth in clean technology investments, the aerospace industry remains focused on electrification and sustainability. Companies are responding to customer demands for sustainable practices, which will likely stimulate innovation and investment in clean technologies amid workforce expansion. 4. Supply chain challenges. While supply chain conditions have improved since the COVID-19 pandemic, ongoing challenges persist, particularly regarding labor shortages and transportation costs. Geopolitical tensions and potential policy changes following the 2024 elections could further complicate supply chain dynamics, impacting the aerospace industry's ability to meet increased demand. 5. Future outlook for robotics. By 2025, advancements in AI, collaborative robots, and mobile manipulators are expected to revolutionize sectors including aerospace engineering. The focus on customization and modularity in robotics indicates a shift towards industry-specific solutions, enhancing operational efficiency and responsiveness to market needs. Timeline of key events and projections. 2024. Continued investment in U.S. manufacturing is expected to create approximately 27,000 jobs, although talent attraction challenges remain prominent. Q4 2025. The aerospace workforce is projected to increase by 50%, necessitating strategic emphasis on skills development and retention. 2025. Robotics technologies, particularly AI-enhanced solutions, are expected to reshape operational dynamics across sectors including aerospace. Comparative insights from sources. Source 1. Deloitte. Deloitte emphasizes broader manufacturing challenges and macroeconomic factors impacting workforce dynamics, highlighting the pressing need for strategic workforce planning and technological investments in manufacturing. Their insights point to the critical importance of AI and digital tools for managing talent effectively in the evolving landscape. Source 2. Robotnik. Robotnik provides a more focused view on the technological advancements in robotics, detailing how AI, collaborative robots, and digital twin technology will redefine operational efficiency. Their perspective highlights the importance of integrating new technologies to meet the evolving demands of industries including aerospace. Source 3. Robotics 24/7. This source features industry predictions on the impact of humanoid robots and autonomous mobile robots in various sectors. The insights suggest a growing integration of robotics in supply chain and manufacturing processes, which will be vital for addressing the challenges posed by workforce shortages. Conclusion. The anticipated 50% increase in the aerospace workforce by Q4 2025 presents both challenges and opportunities for the engineering, manufacturing, and robotics sectors. Addressing talent shortages. Embracing technology integration and prioritizing sustainable practices will be essential for stakeholders looking to thrive in this evolving landscape. As industries adapt to these changes, the interplay of technology and workforce dynamics will significantly influence operational strategies and outcomes. Key recommendations for stakeholders: enhance talent acquisition strategies, develop targeted programs to attract and retain skilled workers, focusing on improved employee experiences and advanced workforce management tools. Invest in technology, prioritize investments in AI, robotics, and digital twin technologies to enhance operational efficiency and adaptability. Focus on sustainability, emphasize clean technology manufacturing and sustainable practices to align with evolving customer demands and regulatory expectations. Strengthen supply chain resilience, implement strategies to address ongoing supply chain challenges and prepare for potential geopolitical disruptions. By strategically addressing these areas, stakeholders can position themselves to navigate the complexities of the anticipated workforce growth and capitalize on emerging opportunities in the aerospace sector. The anticipated 50% increase in the aerospace workforce by Q4 2025 has numerous implications for the engineering, manufacturing, and robotics sectors. Within this context, several counterintuitive insights emerge that challenge conventional wisdom. 1. Talent shortages amid workforce expansion. The expected growth in the aerospace workforce might suggest an abundance of job opportunities. However, the reality is that nearly 60% of manufacturers report difficulty attracting and retaining employees. This contradiction highlights a paradox where an expanding industry faces a significant talent deficit. The projected increase in jobs may exacerbate existing shortages, leading to an estimated 1.9 million unfilled manufacturing positions over the next decade. This situation suggests that the demand for skilled labor will outstrip supply, countering the assumption that growth in workforce numbers equates to easy hiring. 2. Integration of robotics and AI tied to talent gaps. While one might assume that an increase in the aerospace workforce would naturally lead to a rise in manual labor, the opposite is true. The integration of robotics and AI has become crucial in addressing these talent shortages. Technologies such as collaborative robots, cobots, and AI-enhanced automation are expected to fill the gaps left by human labor, challenging the notion that workforce growth is primarily about hiring more human employees. Instead, it suggests a shift towards a more technologically integrated labor force where robots augment human capabilities rather than replace them entirely. 3. Investment in clean technologies slowing amid workforce growth. It is intuitive to expect that an expanding workforce would lead to increased investment in sustainable practices and clean technologies. However, the data indicate a deceleration in growth within clean technology investments even as the aerospace sector aims for greener practices. Companies are reporting a shift in focus due to market uncertainties and a cautious approach to investment. This suggests that while the aerospace industry may aim for sustainability, immediate workforce needs and economic pressures could overshadow longer-term environmental goals, challenging the assumption that workforce growth will directly correlate with increased sustainability efforts. 4. Supply chain challenges persist despite workforce growth. The narrative often suggests that as industries grow and expand their workforce, supply chain efficiencies will naturally improve. However, the aerospace sector is projected to face ongoing supply chain challenges, including transportation costs and labor shortages. Even with a growing workforce, geopolitical tensions and policy uncertainties could further complicate supply chain dynamics. This contradicts the expectation that workforce growth alone would streamline operations and enhance logistical capabilities. 5. Technological adoption driven by economic pressures rather than growth. The assumption that expanding industries will naturally adopt new technologies may not hold true in the aerospace sector. Instead, technological advancements, particularly in robotics and AI, are being driven by economic pressures and the need for efficiency rather than purely by workforce growth. Companies are prioritizing investments in digital tools and advanced automation not just to enhance productivity but to cope with existing labor shortages and rising costs, suggesting that the impetus for technological adoption is more about survival than growth. 6. Collaboration over competition in robotics. Contrary to the traditional view of competition in the robotics market, the increasing focus on collaborative robots is redefining workforce dynamics. Cobots are designed to work alongside humans, enhancing productivity without displacing workers. This paradigm shift challenges the idea that robotic advancements necessarily lead to job losses. Instead, it emphasizes a future where human-robot collaboration becomes the norm, fostering a more integrated and cooperative work environment. 7. Digital twin technology's role is more than efficiency. While digital twin technology is often touted for its efficiency and optimization capabilities, its role in the aerospace and manufacturing industries is evolving. The use of digital twins is not just about improving operational efficiency but also about enabling companies to simulate various scenarios and mitigate risks associated with workforce changes and supply chain disruptions. This broader application challenges the narrow view of digital twins as merely tools for efficiency, positioning them as critical assets in strategic planning and risk management. 8. Long-term versus short-term strategies. The immediate challenges posed by talent shortages and economic pressures may lead companies to adopt short-term strategies at the expense of long-term planning. For instance, while companies may invest heavily in technology to address current labor gaps, the focus on immediate operational needs could detract from the development of talent pipelines and workforce training initiatives that are essential for sustainable growth. This scenario contradicts the expectation that workforce expansion will automatically lead to strategic investments in human capital. In conclusion, the projected 50% increase in the aerospace workforce by Q4 2025 reveals several counterintuitive insights that challenge traditional assumptions about workforce dynamics, talent acquisition, technological integration, and investment strategies. These insights underscore the complexity of the aerospace industry's evolution and the need for stakeholders to navigate the intricacies of workforce growth while addressing underlying challenges. Addressing these counterintuitive realities will be essential for aligning workforce strategies with technological advancements and industry demands. The projected 50% increase in the aerospace workforce by Q4 2025 is a significant trend that will have profound implications across multiple industries, particularly in engineering, manufacturing, and robotics. While many reports focus on the immediate challenges and strategies, several important aspects are often overlooked, yet they hold substantial significance for stakeholders. 1. The hidden talent crisis. While the widespread acknowledgement of talent shortages in manufacturing is prominent, the deeper implications of this crisis often go unnoticed. The report cites that nearly 60% of manufacturers struggle with attracting and retaining employees, a statistic that shouldn't be underestimated. This shortage isn't just a present issue. If not addressed, it could result in approximately 1.9 million manufacturing jobs remaining unfilled over the next decade. What many might overlook is how this talent crisis could hinder innovation and technological advancement, particularly as industries increasingly rely on skilled labor to implement cutting-edge technologies like AI and robotics. Significance: the inability to fill these positions can stifle growth and competitiveness within the aerospace sector, leading to delays in project timelines, increased operational costs, and a potential decline in product quality. Without a strategic focus on workforce development and retention, the anticipated growth could turn into a liability. 2. Technological integration beyond automation. The integration of robotics, AI, and digital twin technologies is often discussed in terms of operational efficiency, but the broader implications for workforce dynamics are frequently overlooked. For instance, The evolution of collaborative robots cobots is reshaping how human workers interact with machines. As cobots become more capable and accessible, they are not just tools but partners in the workplace. Significance: this shift can lead to a redefinition of job roles where human workers focus on oversight, strategic decision-making and complex problem-solving while routine tasks are handled by cobots. This evolution could also create opportunities for new job categories that blend human and robotic capabilities, fostering a more dynamic and adaptable workforce. 3. Supply chain vulnerabilities. While improvements in supply chain conditions post-COVID-19 are reported, the lingering vulnerabilities, like transportation costs and labor shortages, are often understated. Geopolitical tensions and potential policy shifts following the 2024 elections could exacerbate these vulnerabilities, potentially leading to significant disruptions in the aerospace supply chain. Significance: the aerospace industry relies heavily on a complex global supply chain. Disruptions in any part of this chain can lead to cascading effects impacting production schedules and delivery timelines. Stakeholders must proactively develop strategies to mitigate risks, such as diversifying suppliers or investing in localized manufacturing capabilities. 4. The role of sustainable practices. The emphasis on clean technology and sustainable manufacturing practices is often seen as a regulatory obligation rather than a strategic opportunity. As companies invest in electrification and reduced emissions, there are overlooked implications for competitive positioning and market differentiation. Significance: firms that prioritize sustainability not only comply with regulations but can capitalize on growing consumer demand for environmentally friendly products. This approach can enhance brand reputation, attract talent interested in working for socially responsible companies, and potentially open new markets. The intersection of workforce growth and sustainability initiatives could also drive innovation in clean manufacturing technologies. 5. The impact of digital transformation. While the report highlights investments in digital tools for supply chain management and operations, the transformative impact of digitalization on the workforce often gets sidelined. Digital transformation is not just about technology, it fundamentally changes organizational culture and employee engagement. Significance: as companies adopt advanced technologies, they must also foster a culture that embraces change and continuous learning. This shift can empower employees, enhance job satisfaction, and improve retention rates. Ignoring the cultural aspect of digital transformation can lead to resistance, underutilization of technology, and ultimately failure to achieve desired outcomes. 6. The future of robotics, customization and modularity. The growing trend towards customization and modularity in robotics is frequently noted. But the implications for manufacturing adaptability and responsiveness to market needs are often understated. As industries demand tailored solutions, the ability to rapidly adapt robotics to specific tasks becomes crucial. Significance: companies that invest in modular robotic designs can pivot more quickly in response to changing market demands. This agility can lead to competitive advantages, reducing time to market for new products and improving customer satisfaction. As the aerospace industry grows, this flexibility will be essential in meeting diverse client needs. 7. The shift towards a software-driven industry. The transition towards a software-driven manufacturing environment is often mentioned, yet the depth of this shift is overlooked. As firms integrate software solutions into every aspect of operations, from production to customer interactions, the role of data in decision-making becomes paramount. Significance: companies that effectively leverage data analytics will be better positioned to optimize operations, forecast trends, and enhance customer experiences. This data-driven approach can lead to more informed strategic decisions, ultimately contributing to increased profitability and market share. Conclusion: the projected increase in the aerospace workforce by 50% presents both opportunities and challenges that extend beyond immediate hiring needs. Stakeholders must recognize the interconnectedness of talent development, technology integration, supply chain resilience, sustainability, and cultural transformation. By addressing these often overlooked elements, the aerospace industry can not only prepare for growth but also ensure that this growth is sustainable, innovative, and responsive to future challenges. The projected 50% increase in the aerospace workforce by Q4 2025 carries substantial implications for various interconnected sectors, particularly engineering, manufacturing, and robotics. Here are the 4 most valuable points for in-depth analysis and discussion. 1. Talent shortages and workforce dynamics. The anticipated growth in the aerospace workforce is expected to exacerbate existing talent shortages in manufacturing. Currently, nearly 60% of manufacturers report difficulties in attracting and retaining skilled employees. This situation is critical as an estimated 1.9 million manufacturing jobs could remain unfilled over the next decade if proactive measures are not taken. Discussion points. Strategies for talent acquisition. What innovative strategies can organizations employ to attract a new generation of workers, particularly in STEM fields? Upskilling and reskilling. How can companies implement effective training programs to enhance the skills of existing employees to meet the demands of a more technologically advanced workforce? Worker experience. What role does employee experience play in retention, and how can companies improve it to reduce turnover rates? 2. Technological integration and the role of AI and robotics. The integration of advanced technologies such as artificial intelligence, AI, machine learning, and robotics will significantly reshape the manufacturing landscape. The rise of collaborative robots, cobots, and the application of digital twin technology will enhance operational efficiencies while redefining workforce dynamics. Discussion points. Impact of AI on productivity. How can AI-driven robotics improve productivity and efficiency in manufacturing processes, particularly in aerospace? Human-robot collaboration. What are the implications of increased human-robot interaction in workplaces, and how can companies ensure safe and productive collaborations? Digital twin technology. How can digital twin technology optimize manufacturing and maintenance processes in aerospace, and what are the potential challenges in its implementation? 3. Investment in clean technologies. Investment in clean technology manufacturing is crucial as the aerospace sector shifts towards sustainability to meet customer demands for reduced emissions. Despite signs of slowing growth in clean technology investments, the focus on electrification and decarbonization remains strong. Discussion points. Sustainability initiatives. What specific sustainability initiatives can aerospace companies implement to align with global standards and consumer expectations? Financial implications. How can companies balance the cost of transitioning to cleaner technologies with the need for profitability? Regulatory impacts. What role do government policies and incentives play in driving investments in clean technologies, and how might future regulatory changes affect these investments? 4. Supply chain challenges. Even with improvements in supply chain conditions post-COVID-19, challenges such as logistics costs, labor shortages, and geopolitical tensions persist. The aerospace industry's ability to scale and meet rising demand will depend on effectively managing these supply chain complexities. Discussion points. Resilience versus efficiency. How can companies strike a balance between building resilient supply chains and maintaining cost efficiency? Role of technology in supply chain management. What technologies can be leveraged to enhance supply chain visibility and agility, and how can these tools mitigate the risks of disruptions? Geopolitical considerations. How do geopolitical tensions and potential policy changes impact supply chain strategies for aerospace and related industries? Conclusion. The projected growth of the aerospace workforce by Q4 2025 presents a unique set of challenges and opportunities across engineering, manufacturing, and robotics. Addressing talent shortages, embracing technological integration, committing to sustainability, and navigating supply chain complexities will be crucial for stakeholders aiming to thrive in this evolving landscape. Through strategic discussions and analyses around these key points, industry leaders can better prepare for the future and harness the potential that lies ahead. 1. The Industrial Revolution 1760 to 1840. The Industrial Revolution marked a significant turning point in history, transitioning from agrarian economies to industrialized and urban ones. This period saw a dramatic increase in manufacturing output, particularly in textiles and iron production, due to advancements in technology such as the steam engine and mechanized looms. The workforce evolved with a large influx of labor from rural areas to urban centers to meet the demands of factories. However, this rapid industrialization led to challenges such as worker exploitation, poor working conditions, and environmental pollution. Similar to the anticipated workforce dynamics and challenges in the aerospace sector as it expands. 2. The Space Race 1957 to 1975. The space race was a period of intense competition between the United States and the Soviet Union to achieve significant milestones in space exploration. The launch of Sputnik by the Soviet Union in 1957 prompted a massive increase in aerospace engineering and technology development in the U.S., leading to the establishment of NASA and increased investment in STEM education. This era not only resulted in significant advancements in aerospace technology such as satellites and human spaceflight, but also created a demand for skilled workers in engineering and manufacturing sectors. The projected 50% increase in the aerospace workforce by 2025 echoes the workforce expansion and technological integration experienced during the space race. 3. The Information Technology Revolution 1980s to 2000s. The rise of information technology transformed industries by integrating computers and software into business practices, leading to enhanced productivity and efficiency. This revolution created a demand for skilled personnel in IT software development and systems engineering. As companies adopted new technologies, they faced challenges related to workforce training, talent retention, and adapting to rapid changes in technology, paralleling the anticipated challenges in the aerospace sector as it integrates advanced technologies like AI and robotics into its workforce. The need for continual upskilling and adaptation in both the IT sector and the projected aerospace workforce reflects the evolving dynamics of labor markets during periods of significant technological advancement. Future outlook: projected 50% increase in aerospace workforce and its implications for engineering, manufacturing, and robotics industries by Q4 2025. Anticipating a 50% increase in the aerospace workforce by Q4 2025 signals transformative shifts across engineering, manufacturing, and robotics industries. This forecast presents a unique intersection of challenges and opportunities that stakeholders must navigate to adapt and thrive in an evolving landscape. Key predictions and trends. 1. Workforce dynamics and talent management. The anticipated growth in the aerospace sector will exacerbate existing talent shortages in manufacturing, with estimates suggesting nearly 1.9 million unfilled positions over the next decade if current trends persist. Companies will need to adopt innovative talent management strategies, including advanced workforce planning tools and enhanced employee engagement initiatives to attract and retain skilled workers. The focus will shift to fostering a culture of continuous learning and skill development, particularly in high-demand areas like robotics and AI. Organizations that invest in upskilling their workforce will likely have a competitive edge. 2. Technological advancements in robotics. By 2025, robotics technologies, particularly those integrated with AI, will redefine operational efficiency in aerospace manufacturing. The rise of collaborative robots, cobots, will facilitate better human-robot interactions, enhancing productivity and safety. Digital twin technology will play a crucial role in optimizing robotic systems, enabling manufacturers to simulate and analyze processes in real time, thus minimizing downtime and improving performance. 3. Investment in clean technologies. The aerospace industry's growth will coincide with an increased emphasis on sustainability. Investment in clean technologies, including electrification and emissions reduction, will be paramount. Organizations that align their production processes with sustainable practices will not only meet regulatory demands but also cater to market preferences for eco-friendly solutions. The ongoing push for clean technology will necessitate the development of new skills within the workforce, particularly in areas related to sustainable manufacturing and energy-efficient practices. 4. Supply chain resilience and flexibility. Despite improvements since the pandemic, supply chain challenges remain a critical concern. Geopolitical tensions and fluctuating labor markets may continue to disrupt supply chains, prompting companies to adopt more resilient and flexible supply chain strategies. Investments in digital tools for supply chain management will become increasingly important as organizations seek to enhance visibility and responsiveness amidst ongoing uncertainties. 5. Robotics and automation trends. The integration of AI with robotics will lead to higher levels of autonomy and real-time adaptability in robotics systems. This trend will be particularly significant in aerospace manufacturing, where precision and efficiency are paramount. The demand for customized and modular robotic solutions will rise, allowing industries to tailor automation solutions to specific operational needs. This adaptability will be key in streamlining processes and reducing costs. Timeline of expected developments. 2024. Continued labor market challenges will prompt manufacturers to invest in workforce management technologies, while clean technology initiatives will see moderate growth. Q4 2025. The aerospace workforce is projected to expand by 50%, necessitating strategic workforce planning and the upskilling of existing employees to meet new demands. 2025. Significant advancements in AI and robotics will reshape operational dynamics across sectors. Companies will increasingly invest in digital supply chain tools to enhance agility and efficiency. Conclusion. The projected 50% increase in the aerospace workforce by Q4 2025 represents a pivotal moment for engineering, manufacturing, and robotics industries. The interplay between workforce dynamics, technological advancements, and sustainability will shape the operational strategies of stakeholders. By proactively addressing talent shortages, embracing innovative technologies, and prioritizing sustainable practices, organizations can position themselves for success in this evolving landscape. As industries adapt to these changes, the focus on technology and workforce integration will be critical in determining future outcomes.